Mist hangs low over the valley as the river forces its way through stone. Rocks vanish beneath the flow, the edges softened by the force moving over them. Air and water mix into rapids, turning the river white. Where the stream is less turbulent, it runs clear, but still with a powerful current. For most animals, this is an unstable place, a margin too fast to stand in, too chaotic to navigate. And yet, something lives here. A shape moves against the current, low to the surface, its body aligned with the flow. It does not fight the river, it yields to it, holding position where most animals would be swept away, slipping between rapids to probe the rocks beneath. This is the Whio, the blue duck, a duck that has abandoned still ponds entirely. Found only in New Zealand, its Māori name comes from its call, a sharp whistling Whio that carries over the sound of rushing water. In English, it is known as the blue duck, a reference to the slate blue tones of its plumage. Most ducks and geese drift on lakes, wetlands and estuaries, where the surface remains predictable, but rivers like this offer no stability. So what does it take to live here? How do they feed in water that never stops moving? How do they hold their place in a current that never relents? And what happens over generations when a lineage commits itself to the flow? The Whio belongs in the family Anatidae, a group that includes ducks, geese and swans. It is a family defined, broadly, by life on water. But within that shared framework, the ways of using that water vary. Traditionally, ducks have been divided into two main ecological types. Some are dabbling ducks. Think mallards, teals, pintails, shovelers and the like. They feed at the surface of the water, tipping forward to snatch seeds, plants, algae, and small invertebrates from the shallows. Others are divers. Think scorps, tufted ducks, or eiders. They dive underwater, completely submerging themselves to pursue crustaceans and snails, along with other invertebrates, small fish, and various plants and seeds. It is a useful distinction, but it is not a simple evolutionary one. Genetically, the family is far more complex than these categories suggest. Lineages that look and behave similarly are not always each other's closest relatives, and relationships within Anatidae are still being revised as new data emerges. The boundary between dabbling and diving reflects how ducks use water, not necessarily how they are all related. And it is within this already fluid picture that the Whio stands apart. At first glance, it might seem like a bird that should fit somewhere familiar. As the saying goes, if it looks like a duck, swims like a duck, and quacks like a duck. The Whio challenges that idea. It may look like a duck, but it doesn't move through water in the same way, and it does not produce the familiar quack. Yet it is still undeniably a duck, just unlike any others alive today. For a long time, attempts were made to place it alongside better-known groups. Some classifications aligned it with the dabbling ducks, based on general similarities in body plan. Others suggested a relationship with shell ducks, an early branching group within the family. But as genetic data began to reshape our understanding of duck relationships, those placements became less certain. Different studies, using different datasets, have recovered different results. In some cases, the Whio appears closer to one group, in others, it stands apart. Rather than settling the question, molecular evidence has, in many ways, made the picture more complex. What emerges from this is not a clear placement, but a pattern. The Whio does not sit neatly on any of the major duck lineages. Instead, it appears to represent a distinct branch, one that diverged early and has no close modern equivalent. But even this broad statement is still shrouded in mystery and uncertainty. Part of the difficulty lies in the history of the group itself. Ducks diversified rapidly, with many of their major lineages emerging over a relatively short span of evolutionary time. When divergences happen this quickly, the genetic signals that define relationships can be faint, leaving behind a tree where some relationships are clear and others remain unresolved. And among those unresolved branches sits the Whio, distinct, isolated, and following a path few other ducks have taken. And that path leads here, to the river itself. Rivers like this are not simply bodies of water. They are systems in motion, defined not by their surface, but by the force that moves through them. For an animal attempting to live here, that movement creates a series of problems that need to be overcome. The current itself demands constant effort. Even in slower sections, the water is always moving, carrying anything unanchored downstream. Holding position is not a passive act, but an ongoing adjustment, each movement counted, each pause temporary. Where the flow accelerates, turbulence begins to dominate. Water folds over submerged rocks, creating shifting patterns of pressure and resistance. For an animal at the surface, footing becomes uncertain. For one beneath it, the environment is no longer stable, but constantly changing. And yet, these rivers are not empty. They are rich in oxygen and support dense communities of aquatic invertebrates. But those resources are not freely available. They are fixed to substrate, clinging to stone, embedded in crevices, held in place by the same forces that make them difficult to reach. Here, food is not something that drifts. It is something that must be taken from a surface, in water that never stops moving. It is this challenge, feeding in the current, that shapes what the Whio has become. Unlike the ducks we described earlier, dabbling ducks feeding at the surface, or diving ducks pursuing prey underwater, the Whio feeds on the riverbed. Its diet is made up largely of aquatic invertebrates, particularly the larvae of insects such as caddisflies, which cling tightly to submerged rocks. These organisms are abundant in fast-flowing rivers, but they are not easily dislodged. They exist within the current, but are held in place by it. To access them, the Whio does not filter or dive. Instead, it works along the riverbed, positioning itself in the flow and probing the substrate beneath. Here is where one of its most distinctive features comes into play. The bill is soft and flexible, quite unlike the harder, more rigid bills seen in most other ducks, geese, or swans. Rather than sieving water or grasping prey in open space, it is used to scrape and pry, working along the contours of stone to lift insects from the surface. This is not like feeding in still water. It is feeding within a moving system, where the current both supplies the prey and makes it difficult to reach. And so the Whio does not resist that movement. It uses it, holding position just long enough to work a patch of rock, before shifting again, always within the flow. But feeding in the current requires more than the right tools. It requires the ability to remain in place. For the Whio, this is not achieved through strength alone, but through a combination of form and behavior. The feet are large and powerful, providing the thrust needed to counter the flow. But propulsion is only part of the solution. Just as important is how that force is used. The body is held low against the water, reducing exposure to the current. Rather than sitting high on the surface as many ducks do, the Whio maintains a more streamlined profile, minimizing the force acting against it. And even then, it does not rely on constant resistance. Instead, it moves within the structure of the river itself. Fast-flowing water is not uniform. As it passes over rocks and around obstacles, it creates a shifting mosaic of currents, eddies, backflows, and small pockets where the force of the river is reduced. These are temporary, often only body length across, but they provide moments of relative stability. Whio use these features to hold position, shifting from one to the next, working within the flow rather than against it. They do not fight the river, they move within it. And within that flow, a different kind of structure begins to emerge. For the Whio, the river is not simply a place to move through, it is a place to live, and that life is organized along its length. Whio forms strong, long-term pair bonds, often remaining together across multiple seasons. Rather than gathering in flocks as many ducks do, they exist as territorial units, each pair occupying a stretch of river that they defend from others. But unlike territories on land, these are not bounded areas, they are linear. A pair may control a section of river extending for hundreds of meters, sometimes more, following the course of the water itself. Within that stretch are the features they depend on, feeding sites, resting areas, and quieter pockets within the flow. And while the river appears continuous, these resources are not. Suitable habitat exists in fragments, broken by changes in gradient, substrate, and flow. Some sections provide the conditions Whio require, others do not. So even within an unbroken river, space is limited. What appears at a distance to be a connected system becomes, at the scale of the animal, a series of discrete opportunities, stretches that can be occupied and stretches that cannot. The Whio is not entirely alone in this way of life. Across the world, a small number of ducks have moved into fast-flowing rivers, but that number is very small. Among a family that includes well over 100 species, only a handful routinely occupy this kind of habitat. In the rivers of South America, the torrent duck comes closest. It lives among rapids much like the Whio, holding position in turbulent water and feeding on invertebrates attached to submerged rocks. In the northern hemisphere, the harlequin duck uses fast-moving water as their breeding habitat. But they are not bound to this type of environment. Outside of breeding, they live in another unusual habitat for a duck, coastal marine waters. These birds share certain traits: compact bodies, strong feet, low profiles in the water, and behaviors that allow them to persist in powerful currents. But they are not the same. The torrent duck is more specialized still, occupying steeper, faster rivers, and showing even stronger adaptations for clinging to flow. Harlequin ducks, by contrast, divide their lives between river and sea, and are less tightly bound to freshwater currents year-round. And neither shares the Whio's distinctive soft, flexible bill. They are not close relatives. The lifestyle has evolved more than once, but only rarely. And when it does, it follows a familiar path. Different lineages, shaped by the same constraints, arriving at similar solutions. But for the Whio, its way of life is under threat. Not from the rivers, despite all of their challenges, but from human activity and introduced predators. The Whio is currently listed as endangered by the IUCN, and New Zealand's own threat classification system categorises it as threatened nationally vulnerable. For a bird already limited to a linear stretch of specialised habitat, further pressures can be devastating. This is a trend that can be seen in its historic range. While formerly widespread across both main islands of New Zealand, Whio have now been pushed back to a fraction of this habitat. The pattern is clear. In the South Island, Whio trace the mountainous spine of the island, retreating from human-modified lowlands into remote backcountry rivers. A similar pattern is seen in the North Island, where populations persist mainly in upland and forested catchments, largely absent from developed lowland systems. The most immediate threat comes from introduced predators. Stoats, ferrets, and dogs hunt adults, chicks, and eggs, and in unmanaged areas, breeding success can collapse entirely. Even in otherwise intact river systems, Whio populations struggle to persist without sustained predator control. For a species that nests along riverbanks and raises its young in exposed environments, these predators represent a constant and often overwhelming pressure. Other threats compound this: river modification, from dams and diversions to sedimentation caused by land use, alters the flow and structure of rivers, reducing the availability of suitable feeding and nesting habitat. Even where rivers remain, they may no longer function in the same way. At the scale of a duck, a short, unsuitable stretch, a section too shallow, too turbulent, or too exposed, can act as an ecological barrier. Climate extremes, storms, floods, and droughts add another layer of unpredictability to a life already shaped by constant motion. Conservation responses have been intensive and ongoing. Predator control programs are the foundation, with trapping networks and monitoring designed to protect breeding pairs and improve survival. Without these, many populations would likely disappear. Captive breeding and release efforts add another layer, but these are far from simple. Keeping a fast river specialist in captivity requires recreating aspects of a highly dynamic environment: flowing water, appropriate substrates, and opportunities for birds to develop the behaviours they will need in the wild. Facilities such as the Isaac Conservation and Wildlife Trust have developed specialised techniques to do this, raising birds in conditions that allow them to learn how to orient in current, feed effectively, and hold position before they get released. Even with this preparation, success is not guaranteed. I had the chance to witness a release along a local river earlier this year. Young ducks guided into the current, immediately having to negotiate flow and find shelter. It was a reminder that survival here depends on skills that cannot be taken for granted. Management is further complicated by the existence of two recognized subspecies, divided between the North and South Islands. They are managed separately, and only relatively recently has the South Island form been bred successfully in captivity. Now, breeding programs must maintain the separation, adding another layer of complexity to an already demanding conservation effort. Habitat restoration complements these actions. Planting native vegetation along riverbanks stabilizes banks, provides cover, and helps maintain water quality. Monitoring, through counts, banding, and genetic work, allow conservationists to track populations and adapt their strategies over time. All of this reflects a central tension. The Whio evolved to live in rivers defined by continuous, unbroken flow. Humans are now attempting to recreate, in fragments, the conditions that species depend on. And while progress is real, some rivers now support stable breeding pairs. The system remains fragile. In a world where rivers are altered and predators persist, the Whio endures as both a success story of conservation and a reminder of how narrow the margin for survival can be. The story of the Whio began as a question. What does it take to live in a river that never stands still? But by now, the answer is clearer. This is a bird shaped by constraint, by current, by turbulence, by a world where stability is never given, only found in motion. Its body, its behavior, even its place in the tree of life, all reflects that history. A lineage that diverged early, following a path few others have taken, into a habitat few others have occupied. And it is a fragile path, because the same specialization that allows Whio to live in fast-flowing rivers also limits where it can survive. Not every river is suitable. Not every stretch can be used. And when those systems are broken, by predators, by modification, by fragmentation, there are few alternatives. Across the world, only a handful of ducks have made this transition, different lineages arriving at similar solutions. But only rarely, and never easily. The Whio remains one of the clearest expressions of that idea, a species defined not just by what it is, but by where it lives, a river bird in the most literal sense. And in the end, it does not fight the current, it moves within it. I hope you enjoyed this journey into the Whio. If you're interested in the research behind this episode, you can find a document with image credits and sources in the description below. These videos take a great deal of time and research to produce. They will always remain free to watch. But if you would like to support the channel and gain access to new videos a little earlier, you can find a link to my Patreon below as well. If this video sparked your curiosity, don't let it stop here. Share it, talk about it, and keep learning. There's still so much to discover about the world's rare and remarkable species. And the more we understand, the better our chances of protecting them. Thanks for watching.